Hey everyone, welcome to another Manufacturing Live. We have a special Friday edition, so please pull up your favorite beverage of choice for Friday morning or Friday afternoon. But today we have a really cool guest, one of my longtime friends. We've been through some battles together over the years. Chris, tell everyone a little bit about yourself.
Well, Mike, first of all, thank you so much for having me. Yeah, for those of you that don't know us, we've gone back a long time. We were AEs together. We started out together. I've been an AE for several CAD CAM systems. Most recently, I was employed by Hewlett Packard to help them with their industrialization of 3D printing. But throughout my career, I've been in and out of shops. I started as an injection mold maker. Jeez, I don't even want to say how long, Mike, right? Like, how long have we been in this industry? Yeah. All of a sudden, we're the old guys. It's crazy. Yeah, it's just been a really great trip. And my whole career has just been in and out of just some really amazing small shops and big shops. And manufacturing just really, really excites me, man.
Yeah, so rule number one is we never give away our age. The gray does that for us, but at the same time, let's just say we were around before the three mouse button was available. Let's just put it right. That scroll wheel in the middle wasn't always for rotate in SolidWorks.
The first CAD system I used was AutoCAD, and I had one of those tablets and a little crosshair where you had to go on the tablet. Oh my gosh.
Yeah, the digitizer.
Yeah. Kids these days.
Yeah. What's this touchscreen stuff? Like,
That's
there's
right.
no thing. It's demoing with an 80-pound CRT. So we have a few days of experience, and we've been chatting quite a bit lately. And you mentioned your journey from working in the shops to subtractive. Then your most recent challenges have been additive. Let's start by talking a little bit about how you've seen the industry change over, we'll just say 5 years, because we all know that we're going to talk bigger than that. But to help our egos, sure, we'll just say our career has been 5 years, right?
Yeah.
So from the digitizer to today, what are some of the trends that you've seen that have really sort of been shocking?
Yeah, so that's really interesting. I think there's been a real amazing shift in mindset from both owners and machinists about the way technology can interplay with kind of the old school ways of manufacturing. When I started out, I remember the first 3D printed part I saw was in the early 90s, and one of the older mold makers said, "Oh, that's going to put us out of business." That was their fear, and it has been that fear, like 3D printing, or it was just poo-pooed and it's nothing. But I think in the last 5 years, there's been this adoption of 3D printing can really help us as machinists. Jigs, fixtures, things like that. A lot of them need post machining and things like that. Now I'm talking about 3D printing, but you asked about technology in general and like what the trends are. Yeah. There's so much computing power with Industry 4.0 now, from scanning entire warehouses to unbelievable machining simulation. It's crazy, and the information that we get because of all that. I see there's this big push for almost working smarter, not harder. It's really kind of went that way in the last 5 years.
Yeah, it's an interesting thing, right? Because I talk about this when I talk with customers and everything, and so I'm probably full of it, but we'll chat back here and you can tell me if there's a thing to it. But when you look at like the Industrial Revolution, right? Like in high school, hopefully, we all learned about the cotton gin and Ford and the assembly line and all of those things, right? That was Industry 1.0, 2.0, where we're talking about mechanization and then assembly,
interchangeable
right?
parts, sure.
Yeah. And Industry 3.0 sort of went under the radar because everything just progressed, right? And now we hear this thing called Industry 4.0, and some people are like, I've never even heard of that. And it's like, well, you have heard of it. It just was in relationship to history, not what we're doing today. And to me, the interesting concept that's come out of this is, especially, I think everywhere in the world, but especially here in the US, the answer has always been, if I need to get more done, I just get more people. And unfortunately, there aren't more people.
Right.
So you have to work smarter than you used to. And I think the other thing that comes in is technology is more affordable than it once was. I mean, you think back to our days, think about, the first CNC machines people put in their shops, right? I mean, isn't that sort of what you're seeing, and like where the additive component and some of those came from is like, look, we don't have more people.
Right. Yeah. I mean, absolutely. I think it's that. And I think you touched on the affordability of machines too. Advanced 5-axis mill turn machines. There's another thing in the last, I would say, 5 to 10 years have become affordable and necessary. I'll go out on a limb and say necessary in most shops because we don't have the people. We don't have somebody that can, okay, we're going to give that to him to turn, and then we're going to put it over there to mill, and then back to this guy for this. It all has to happen. Not only is it really efficient, and the machines are much more rigid than they used to be, but the work itself almost demands it, and the prices have come down. So I see a lot more of the higher end, well, what we would consider higher end machines in shops, for sure. 3D printers, it's tough. I see them in shops, and it's kind of on the brink of really being an integral part of any machine shop. Some of the more advanced ones, like I said, use them for jigs and fixtures, the plastic extrusion machines. The metal machines are really great for prototyping, but they really haven't made it into the machine shop yet. But yeah, I definitely see that technology coming up.
Yeah, like it's an interesting thing, right? Because I like additive. I think there's some amazing things that happen with it. And I think that it's going to get there. I still personally believe, and I've talked about this before, but I think the future is the mixed machine, additive and subtractive in one machine, because to me, building subtractive and additive on separate paths that you still have to merge together to get the finished product, all we've done is replace the 3D printer with replace the bandsaw with a 3D printer. So right. instead of cutting the bar stock, we now have a more finished component, which helps. I'm not saying it doesn't help, but I think if you're looking at mass market capacity, it's got to be a hybrid. For me today, I don't see how it works without it, because if you print a part, you still have to have high tolerance machine surfaces. You mentioned something that I want to go back to too is, and we'll talk about our age again here. Do you remember when we first got into this business, right? You'd look at a 2D print that would come in, and like everything that was 10 thousandths or looser was dimensioned on a print, right? Because if you were running it on manual machines, like 10 thousandths, like you had to make sure you put effort into making 10 thousandths of right. tolerance, right? And when you come and look at it today, it's like that's all taken for granted with the automation and the ability for a machine just to hit 5 to 10 all day long without even sweating it.
Oh yeah.
Have you seen that transition? Because I sure have, to where the dimensions on the print only come down to like anything less than 10 now, I want a dimension. Everything else, we just know we're going to hit that.
Yeah. That's a really great point. And I think I've seen in the last 10 years too, a much more, a bigger emphasis on GD&T. And I think this goes to exactly what you're saying. Instead of just all of these dimensions, we're machinists. We know we used to get these prints. I used to get these injection mold prints that had, it took a day just to figure out what all this stuff was. And now we have these 3D models. We don't have to worry about this. How many times have you gone to the engineer? Hey, does this matter? Hey, does this hole's dimensioned weird? Well, now you have this 3D model, and you don't have to worry about it, right? So you have these, just the call outs of what needs to be machined or be important. But even going back further, I'm going to sound like a crabby old machinist here. And you talk about getting prints back in the day and how they were dimensioned. It's so much easier now in any CAD system to just increase the number of decimals and say go. And I think we as machinists have gotten prints like that you have a hole that is 0.2500002. It's like, really? Does it need to be that? So, I think there's a combination of those two. I think the ease of adding the tolerances like that, even though you don't need them, kind of contributed to seeing more of that. But as far as 3D printing goes, yeah, you're right. I mean, it's so much easier to just make a model, make sure that it's, you know, 2-dimension in the model, and then print it. Yeah, for sure.
Yeah. One thing, you know, I was so excited to chat with this morning. I do have to throw out something here quick. I got to do some housekeeping.
Go.
For everyone that's just joining, please make sure you hit like and subscribe. You know, we have these monthly. It's the, you know, generally the first Tuesday of every month, but some of them are changing. We have an exciting one that I'll talk about at the end of the show coming up, but please hit like and subscribe. These are monthly ones. And also, this is truly live. So if you have questions, please ask them. You know, the one from last month, we got asked about doing taxes with DriveWorks. So I'm expecting a top of that for Chris today. So housekeeping is done. So awesome. To this tolerance thing, since you just came fresh off doing some additive stuff, right?
Yeah.
Going through that process. Explain to me how different it is to design for additive production runs than it is to design for traditional manufacturing processes.
Yeah, that's a really deep question. You know, design for manufacturing has always been at the forefront of everything. Undercuts, you know, outside radii, or, you know, do you need these things, you know, rounded corners, things like that. Excuse me. But now it's even more because the capabilities of the 3D printer, forget about undercuts, forget about closed holes, you know, different dimensioned holes, having larger holes. You don't have to worry about reaming, you know, the second stage hole or something like that. And I think just now, from what I've talked to the students that I've talked to, colleges are really starting to do that. You know, the kids that would come out of engineering school way back when, I mean, they would, they had a pretty good idea about design for manufacture, but I think now the younger generation that have come up with 3D printing, they know that they're able to, you know, do undercuts, do really crazy designs, iterative designs, things like that. And it's really kind of excelled 3D printing because it's really kind of emphasized. One of the projects I worked on was a speaker, and it was a circular speaker, and it was an amazing project, but it's something that you could never machine. I wouldn't even begin to think how to do that. The caveat to that is, you know, it was definitely designed for printing. You know, so here's an engineer that had this great idea. I think he was a sound engineer. Wouldn't it be great if I could ... Yeah. So being able to start like that is really huge. And I think that, again, the younger generation is doing a really good job of that and keeping that in the forefront, because they're not taught that, no, you can't put that on a print. Like, no, that's not right. Yeah.
Yeah. Well, and you know, it's interesting. You talk about that what if idea. You know, I do a fair amount of prototyping for the what if crowd, right? and it used to be I would design it and check it and do all those components, and then, you know, I'd go cut it out as heck. I've even cut stuff out of wood, right? Just especially now when you're talking material prices so high. But, you know, about a year, it was about a year and a half ago, I added a small home printer, right? Like, it's not small, like it's large envelope, 12 by 12 by 8 or something like that. Oh, cool. And I just got to the point now where it's like, if someone has an idea, I just quick knock it out in CAD, drop it over there, print it, take it to them, and be like, okay, spend a day or two with this, come back, tell me what you like about it, and then we'll narrow down the manufacturing process to actually make this to where you could go make, you know, 100, 200, 300 at a shot. So I've changed my process a little bit just because of the fact that it's easy to knock out the idea that they want, print it, give it to them, let them hold it and play with it. You know, I don't go to the extent you were talking about where it's a sound engineer with some crazy wild shape. You know, for me, it's more of like, I just don't want to waste my material. And it seems like in the past, we would waste a lot of expensive material on what if scenarios.
Oh, you're absolutely right. You know, the majority of my career in the shop was as a model maker. You know, I was lucky enough. I think the Stratasys, their FDM machine, I got like number 8 off the assembly line way back when I was in a model shop in Chicago. And, you know, back then we were doing everything out of 20-pound foam and Ren board, and it was great. And then all of a sudden this 3D printing thing came, and it was like, hold on a second, you know, this is making life a lot easier. And yeah, you're absolutely right. For prototyping, yeah, that is definitely the way to go. for sure.
So you mentioned Renboard.
Yeah.
So
yeah.
I cut
I
some
think
of
I
that.
still have some in my nose.
Yeah. So I cut some of that on my router. And how did you handle the static electricity that came off of that stuff? It
Yeah, it's
stuck to
crazy.
everything. I mean, granted, I lived in Colorado, which was extra dry anyway, but I was like, the bane of my existence was trying to clean that up when I was done.
Oh yeah, absolutely. And there's so many different types of it. I know the exact type you're talking about. Was it the kind of the red stuff, right? It
Yo,
just got
yes.
all over the
Yeah.
place. Yeah. Yeah, I joked when we brought that up that I still have some in my nose, and you ask how I cleaned it up. I don't know. I don't even remember. I think it had an effect on my brain or something because you're right. It gets everywhere.
Yeah.
It's an amazing material for those that haven't used it.
Yeah.
It's Ren Shape or Ren Board. It's really great. It's got it's I think 25 or 30 pounds something. I don't know. It's really thick and nice, but
It's
yeah, it's
really
a mess.
stable. Like it
Yeah,
machines really well. The finish is really good. I did like this surfacing surfboard thing, and
awesome.
like the finish was amazing on it. However, like I tried everything. Like I went and got like the static cling static guard, you know, you spray on your
Yeah.
dresses, and I was trying to spray my machine down because it was getting caught on everything. I'm like, this is really cool stuff to machine with, but I don't know if I want to do it again.
Yeah.
You know?
I don't blame you for sure. That's so funny that, there's two types of machinists, the ones that just close the door and clean up afterwards, and the ones that are like wiping down the windows as the machine's running. And I think you're the latter of them.
I am, because I've always been picky, you know, of like the companies that I ran. It's like there could be a tour coming through at any given time, and I want to make sure that our facility is presentable as possible to get more business, right? And then I've worked with people that were like, oh yeah, the door's open, the coolant's flying out on the floor, and like, what are you guys doing? Like, we cannot work this way and impress future customers. Like, that's not the world we want to live in. But
you're right. And what's funny is I found that people that aren't familiar with machine shops, they won't recognize a clean one, but oh man, they will know a dirty one for sure.
Yeah. Well, and so that brings up a good question, right? And I asked this of a lot of people. I asked this to a large group about 3 or 4 weeks ago, and there was no response, and it floored me. Do you think that we have an image problem in manufacturing as a whole?
Oh, absolutely, without a doubt. Oh yeah. Yeah. I think, yeah, go ahead, please.
Well, you made me feel better because one person said no, and I'm like, what planet do you live in?
Right? I know.
So explain what you think the image problem is, because I like to listen to everyone's perspective because I don't know the right or wrong answer. It just makes me think.
And please know that I don't know the right or wrong answer. I can just give you my opinion. And working with education throughout the years I had, with software, there's always an education department, and working with schools and stuff, I've really found that, every parent wants their kid to be a doctor or a lawyer, right? Be a doctor, be a lawyer. They want to go to college. They want that 4-year degree. They want the stuff. At least it's been like that in the past, I think, over the last 2 or 3 years, probably since COVID has changed. But generally speaking, you doctor, lawyer. And then really, when you think about it, there's such a stigma about working with your hands. I made air quotes, but I didn't want to do it on camera because it's super cheesy. But okay, great. I don't want to work with my hands, But it's funny, my apprenticeship, I was on that same direction. I went to a college prep high school in Chicago and everything. And I ended up doing my apprenticeship. And to be honest with you, when recessions, depressions, inflation, all this stuff, I always had a job. Always had a job. So there's definitely a plus to it, but there's this image of, those old metal workers like blacksmiths, right? Sparks flying all over the place and you're all sweaty, but that's not it. And people don't realize, I think, maybe it's our fault. We're bad at marketing our career maybe, but honestly, some of the best mathematicians I have ever met were machinists, without a doubt. I mean, the way that they know trig, it's just off the top of their head. It's incredible. And the intelligence that it takes to be a very good machinist is really high. But again, people don't see that. They see the dirty, you got to work with your hands, and quote unquote machine shops. I don't think people really understand what a machine shop is. I think they imagine a big engine in the middle with grease all over the place or something. But again, I think it really starts in two places, right? Letting people know that it's okay that their kids have a career that they don't have to wear a tie. Right. I don't think anybody wears ties anymore. There you go. There I'm old again, but you know what I mean? Like a professional career. And the other thing is in the schools, telling kids that, hey, you know what? It's okay if you like to take things apart in a corner while everyone else is reading or things like that. Like it's okay that you like to make things. Yeah. You know, let's enhance that. You know, there's this path, right? There's this manufacturing path that's amazing. You know, and I think that's it. So, yeah, I mean, I do think that we have an image problem. And I do believe that that's one of the reasons there's not a lot of us, you know, anymore. I shouldn't say that. There are a lot of us, and I am really excited about the machinists that are coming up. You know, I've heard a lot that, oh, you know, these kids these days, but yeah, it's a great direction that we're going. And what I'm hoping is with the social media, the TikTok, the Instagram, not Facebook, because old guys are the only people that use Facebook, but those younger ones, right? Yeah. They post these videos of machining and finished parts and 5-axis stuff. And, you know, you've seen those videos of machining motorcycle helmets and things. That's the stuff that younger people are going to see, and it's going to change the image of our industry. And I think it's really important to get that material out there and encourage our customers and our peers. Hey, that's awesome. Post that. That's amazing. You know, because people get excited.
Yeah, I agree with everything you said. And I think that, you know, I got a question for you coming up to change the topic here, but I want to finish up on this. I think the interesting thing is, you know, when I hear people say, oh, the kids these days, first of all, when we were coming up, the generation before us were like, oh, the kids these days, right? Mm-hmm. And then you snap your fingers, look around, and all of a sudden we're expected to like be leaders of this thing. I don't know how that happened, but the idea here is, I think the problem is not the kids these days. That's like the get off my lawn excuse, right? I think it's the more of, I don't understand the position you're coming from. And I think the challenge today is it's easier just to write a group off than it is to try to understand. And I think that leads to a lot of our manufacturing problem. I also think that traditionally manufacturing has been very closed off. I have my niche, I do, and I am not going to talk to anyone else about it. And in today's world, you have to change that mindset and you have to open up and collaborate on a bigger scale, because you're now competing with everyone on the planet. It's not just, well, I can't talk to that company down the street or around the corner because they might go steal my customers. It's now, if you guys don't learn how to collaborate together, you're probably going to lose business for the entire community. Mm-hmm. And I think that that's a change, and it's a mindset that the people at the top have a hard time with. I think the younger generation want to communicate and collaborate. Mm-hmm. And when you put them behind oh, wait, no, you can't talk about that. You can't share that. You can't be with your friends. It's like, well, I grew up in a social environment, right? And now you're telling me I can't do something, so I don't want to do it. I also think that because you and I started with digitizers and board drafting, it doesn't mean the next generation has to start that way either. Right. And the same goes for machining. Mm-hmm. You and I started on manual machines. That does not mean that tomorrow's manufacturing machinist has to start on a manual machine. And I've seen some schools make that mistake as well.
Oh, yeah.
You know, it's like, well, because I did this and I earned my badges this way, you have to go through it. And if you don't, then you don't qualify. And that kind of stuff, I think, leads to our problem, you know?
I absolutely 100% agree. And I think that segregation that you're talking about externally, like this kind of working in a silo and, you know, don't tell anybody. I think that also applies internally to a lot of companies. I think the shop is this mysterious place. Maybe it's on-prem, maybe it's not. I don't know, but we just throw prints over there and these bunch of crabby old guys make this stuff and give it back to us. And it's just weird, you know?
Yeah.
But, you know, collaboration now, again, I don't want to overuse it, but Industry 4.0, all of the data that is attached to everything that we do now, it just makes sense to collaborate with that. It makes sense. It makes everybody's job easier to know what the other person is doing, the other department's doing, and all being on the same page. I agree.
Well, and it takes a bigger group to solve a problem today than it did 25 years ago. Like you need more input to be successful. And that throw it over the wall thing no longer works, because throwing it over the wall within a factory means that engineering is like, those stupid people in manufacturing, those stupid people in engineering, versus, okay, let's come together and come up with an idea that actually makes sense for everyone to benefit, because nobody wants to do extra work. We just are used to this custom of, well, not my problem, right? So with that, I got to change direction because there's a really cool question for you.
I'm ready.
What is the most favorite project you've ever worked on in your professional career?
Wow, there's a lot. There's a lot. I'll tell you what, I'll do a few because I've had a few different roles in my career. You know, when I started out as an injection mold maker, one of the coolest things we did is we made zip sockets for computers. So it's basically what the chips go into and things. Super high precision. At the time, I didn't appreciate it, but looking back on it, these molds were so complex. These zip socket molds. Learning how to do these in the beginning of my career really set that standard high as far as precision machining goes. So those were absolutely great. In the model shop, that's a tough one. I've done things from refrigerators to beepers. There you go.
Okay.
I did Motorola's beepers and stuff. But I think the coolest thing in the model shop is there's a water pump for a helicopter, right?
Okay.
And just to get a prototype, right, takes 12 months. And they could put it on and it not work. Oh, now we got to go back to the drawing board. In the model shop, we both, and I feel like I'm pressing 3D printing, but I'm not. It just is a coincidence that we printed one, did some machining on it. All together, it took 23 hours to get it on and off the helicopter. That was cool. That was really, really neat, you know. And it's funny, you know, people say like, what's the cool project as a machinist? And we do so much stuff. It's hard to say like, I made a rocket ship or something. Really the cool things for me, and I think the other people we talk about are the cool applications, right? It's not the cool parts. It's, hey, I helped SpaceX. Like I helped with the company that does their turbos. That was cool. You know, things like that. Yeah. How about you? Did anybody ever ask you that? What was the coolest thing you've made? I've seen a lot. That recycling thing was cool.
Yeah, it's hard for me to narrow it down. I think because I blab so much, nobody wants to hear from me. But you know, it's sort of like you. It sort of falls into sections, right? I think in the early days for me, we did when I was doing like programming lasers and running lasers and press brakes, we used to make this conveyor system thing that would go in a hospital. We're talking like 2001-ish. And essentially what it would do is it went between all these different floors, and it was this conveyor system that ran, and any room could drop in like their test tubes and all that stuff, and it would go to the right place without anybody walking around a facility. Way ahead of its time, you know, back then, right? And we were doing these sheet metal housings, laser cut, this small little shop in Omaha, which is still one of the places I learned the most. But we were cutting, bending on an old mechanical press brake and building those things out of aluminum and within 10 or 15 thousandths tolerance of these boxes after they're all TIG welded, you know. That one was pretty cool just because that was my first like experience programming lasers and getting really good at running lasers. There was another one, you know, when I was in AE, one of the coolest things that I ever got to go see is there's a company out in Western Nebraska. And as you know, this going to all these shops in our time, right? You go out and you drive out, and we pull up to this building, and it's in this rural location, like legit rural, and it looks like a Morton building. And you walk in, and they build aerospace components. And sitting on the table was the dash for an F-16. They make the molds that make those pieces, right? And they're like, okay, this is what we want to solve with Solidworks. And I was like, that is one of the coolest things I have ever seen, you know?
For sure.
It's just in the middle of nowhere, Nebraska. The recycling thing was really awesome because I got a really good education real quick on, you know, services and back charges and like filling 2 football fields worth of a building with just equipment all the way to the floor, wall to wall. And then all the controls and PLC that went into it, like that, the one we did in the Bronx actually had a full command center and everything was tied up in real-time process monitoring. And, you know, that was an interesting thing. The people that go into making recycling were always intriguing to me. You know, like we went up and did a conveyor in Alaska, and it's actually where this thing sits is for the cruise ships to come in. So the cruise ships come in, they dump all their garbage out while people are on shore leave, and then it goes in these conveyors and gets recycled and hauled away. And it's things like you never think about that when you're on a cruise ship, right? Like every time they pull the port, tons of garbage have to come off, right? And it has to be sorted. So there's cool things like that, but it's really hard to narrow down because I really enjoy, for me, seeing a company take a piece of technology and like run with it and just like completely transform their business. To me, that's always been the coolest thing.
Absolutely. I have two really quick stories I know about that. You're talking about shops in the middle of nowhere. I was in the middle of Texas, right? And the customer said, okay, you're gonna go down the street, you're gonna go down the road. It wasn't even a street, a road, and you're gonna see a sign that says mules for sale, right? You're gonna see that and you're gonna make a right. I was like, are you kidding me? So sure enough, and it's this dirt road, it's in the middle of like this forest in Texas, crazy one. And what he built were the frames for the cameras that when there's an oil leak, like remember there was one in the Gulf and they had cameras that shot at it.
Yeah.
He made those rigs that went down into the ocean and all this stuff. It was amazing. It was great. I mean, these small shops are they're amazing, for sure.
Well, and you talk about people that know math and people that are next level thinking, like you get out in those rural areas like that and they're doing this really cool stuff. And a lot of times it's like, well, I don't even understand how they're doing it. And it's like, they could have been anything they wanted. They chose to be in manufacturing and we all get to benefit from it, right? Because they're very intelligent, next level thinking, problem solving. And I think for me, I think what gets missed with manufacturing is at the end of the day, whether you're a machinist, an operator, a robot programmer, or someone on the assembly line, to solving a problem to get a product out the door that someone's going to use. We're problem solvers, but that gets overlooked by the idea of dirty, dingy,
Oh, absolutely. I mean,
Steel Town, that kind of stuff.
Well, I mean, we always lament about, always being forgotten and, nobody appreciates the machinists. And realistically, I agree. I mean, there are no parts, right? The way that I tell people like what is manufacturing, right? Like look around you. If it doesn't grow out of the ground, somebody made it.
Yeah.
The bricks behind you, the picture behind you, the computers that we're talking on, somebody made it, So it's an incredibly powerful thing for sure.
Yeah. Well, and so I threw out Flashdance. So I got a story for you. So I was out doing a presentation the other day and I was talking to a group of people and I said something about max headroom and one person was like, you realize that I'm the only person in this room that's old enough to know who that is. And I'm like, there's Google. All of you go Google it. So for the people out there that have never heard of Flashdance, just go Google it. You'll thank me later. I went to, I was talking to someone and I was like, oh yeah, you remember what life was like before iPhones, right? Because they came out in 2004. And the guy was like, I was 8 years old. And I'm like, thank you for making me feel really old. I will change my discussion on that. That's a bad on me.
It's funny though. Speaking of that, just really quick, you're talking about cell phones in the shop. Like that is something that's new in our time too. Like back in the day, like you didn't have that distraction. Like the old guy would read the paper, but now you got to worry about kids on their phone. Sorry, so old. You have to worry about machinists on their phones and all that other stuff all the time. It's interesting.
Well, it is interesting because remember, like, we had the bag phones, and then you probably had the Nokia, the one that was about this tall. It wasn't the flip phone, but it was the first.
Oh yeah, the indestructible one, yeah.
Yeah, the one that they probably still use to hold up CNC machines in shops.
That's the one.
Yeah. Well, what's funny about that is you remember you went to work in a shop, and it was like you put that in your locker. If that's seen out here anywhere, it's like you're gonna get fired or sent home.
Mm-hmm.
And now today it's like tablets, barcode scanners, touchscreen TVs, monitors hanging up above, it's like all that stuff exists and it's just all second nature to now, like, why don't you have that? And I think that's some of the challenges when we talk about Industry 4.0 is we're still sort of stuck in that all your personal stuff needs to be in your locker. You just do what this thing says,
Yeah, no, you're absolutely right. And I think that's kind of the catch-22, right? I mean, we want to be connected, but we also want to be focused on work and safety for sure. I mean, that's another thing is I sound so old, but yeah, I mean, there is definitely a safety issue there too.
Yeah. Yeah. Safety is an interesting thing. I have a wild story of that from my recycling days, but that's probably for another day. That one's a little bit of a downer. We're here to be happy.
Yeah, let's not talk about that one.
Yeah, we're not going to talk about.
We'll save shop injuries for a special edition, right? Like after dark shop injuries or something.
Yeah, Christmas. We'll save it for Christmas.
Yeah.
Make everyone feel thankful as they go on the holidays with their.
You're absolutely right that they have 10 fingers and 10 toes.
Yeah. Yeah. From a couple of years ago, I think we have Four Finger Johnny or something like that in one of our skits. You know, so I got a question for you.
What's up?
Why do you believe that manufacturing is mostly men?
Oh, that's a great question. No, I totally get it. No, I totally understand it. It has to do with women in STEM. It really does. I mean, I don't know that girls in school are pushed as much as boys are. I think it's starting to change now. You know, there's that wave, but you know, having girls interested in STEM. Now I have a daughter, she's 18, right? And I saw it firsthand. She loved math. She loved it. And then there was this weird switch where all of a sudden she didn't. And then the boys kind of split up from the girls, and the boys were really into math and science, and the girls were kind of more into the general ed stuff. And it was a really strange phenomenon for me. So I really do think it starts there, is really pushing, you know, all of it, not just machinists, but STEM in general, or STEAM now, right? They added an A somewhere.
STEAM. Art is added to it.
Art, yeah, that's right. Geez, I should know that. But I think that's really what it is. I think historically, it's a male-dominated field because of that, because it's always pushed that engineers are men with the plastic pocket protector and the glasses and the tie and things like that. I would love to see a change. Honestly, I can think off the top of my head 5 female machinists that I would hire in a second. I mean, they're whatever. I mean, male, female, it doesn't make a difference. You know, I mean, you can do the job. So that's a great question. Like, why aren't they? And I really do think that it's encouragement from a young age, sorry.
Yeah, I would agree with that. And, you know, you mentioned people, you know, dudes have egos, man. Like, I don't know how to explain it in manufacturing, but it's like everyone turns into Planet of the Apes gorillas, and it's like this ego drama show thing. Like, and I know I'm generalizing here, but I'm generalizing for effect, right?
You're right.
But, you know, in my time of, like, I've had women welding, women machining, women, you know, doing all that stuff. And it has always been, we're here to do a job, more times than not, better at it, because they have to overcome all the BS that happens to even get to that point in their life. Mm-hmm. You know, and I just think it for one, it's 50% of the workforce, but the other thing too is, like, it just makes sense, you know. And my wife is a vet, you know, and when she started, you know, it was mainly male dominated. And now veterinarians are like 80% women, and, you know, no woman wants to go out and work with some crotchety old farmer that believes men should still be doing this, right? So now there's a shortage in that, and it makes me think about what our future is in manufacturing, because I think part of this digital transformation and Industry 4.0 is going to drive that change to where, like, you can't just be the crotchety old person in this organization, because to move forward, you have to have different thinking, you know. And it really bothers me. Like, you know, you go to school and you see that influence, and you see some of this. Well, yeah, we say you can be anything you want to be, but secretly we're going to tell you should probably move yourself over here, versus just being like, hey, you go figure out how to be the butterfly you are. You know?
Yeah. No, you're absolutely right. And again, you know, I think, and this isn't political, this is just the truth, you know, the push now with the STEAM and making sure that there's inclusion in these programs, that they're not just for, you know, boys, males, men, whatever, or even economic status. Like, we really need in manufacturing to open our arms up to everybody and say, hey, this career is amazing. It really, really is. And it's the cornerstone of what America is. I mean, the American manufacturing, to me, is just, it's amazing. And it's this thing that I don't know that a lot of people have access to. So I think that with the push for STEAM in schools, it's going to improve a lot.
Yeah, well, and there's two thoughts I have there. I heard,
Hmm.
we talk about Steam, and I'm all for art being part of that. I've heard some
Hmm.
people being like, "Oh, art, it doesn't count," and it's like
Hmm.
you can't sell a product unless it has an aesthetic design today. So you sure as hell better know how to make something aesthetically pleasing, which is art.
Hmm.
A lot of everything I design and build is based on my time in high school and art. Ceramics. We did all kinds of processes, learning about the history, understanding what Art Deco design was, all of that stuff. Like anytime I sit down and design a product for myself and ever have, it's always been what's going to be pleasing to the eye because I can't sell it if it's not that way. So to
Hmm.
me, art was always a piece that was missing when STEM started out, because being able to mash buttons on a computer to make a design mean nothing if it's not pleasing. If you don't believe me, look at the iPhone. Uh,
Yeah.
the iPhone changed the market, and it wasn't because it was the Nokia brick. It was
Hmm.
because it was aesthetically pleasing and people wanted it. Um, the other thing you brought up Industry 4.0, and you brought up American manufacturing. I think what very few people understand is every country has an initiative to improve and digitize their manufacturing process, and it's not for marketing and make us feel good like some recycling initiatives are, frankly, where
Hmm.
it's like, oh yeah, pat yourself on the back, you recycled today. The race is because companies or countries that manufacture and produce have more power in the global economy. If you are a country that just consumes, you are in a weaker position in the world marketplace. So the reason you have China 2025, Industry 4.0 here, you have several different initiatives. I think Germany has one, France
Hmm.
has one, the EU has one.
EU has one, yeah.
Yeah, the reason all of those things exist is because manufacturing has traditionally been nomadic because you require a workforce to do it, a labor force, right? So they moved wherever the cheapest labor was. Once that raises up, then they move somewhere else. With digitizing things and using robots, it's now becoming a political play from a global scale, right? So there's a real big race and push that goes on right now of being able to be in position to manufacture for the next 50 years because that gives you your place in the world. And when you understand it from that point, and then you look at the fact that it's mainly dudes in the US, you've
Yeah.
just cut your potential market and capability by 50%, and you're only thinking about it from an egocentric standpoint, right? And I think that when you're trying to compete on a global scale, you need everyone to be involved to solve these problems.
Yeah, you're absolutely right. And we talked a little bit before about working in silos, like both internally in a company and, now this is the exact opposite. This is a macro
Yeah.
version of that, right?
Yeah.
And, um, made in America still means a lot. It still means a lot globally. We're renowned really for, getting parts out, good parts, that people want. And, we still are, even though there's a little bit of a dip, and I don't know that that's our fault necessarily, but you're right. I mean, I was actually researching just a couple of days ago some government programs around manufacturing actually, and there were ones in there I had no idea about. I mean, there were ones, I encourage anyone to Google it, manufacturing government programs or something like that. And there were everything from small shop aid to large company organizational grants and things like that. There really is a push in the government, to have manufacturing grow again. And it's really exciting.
Yeah. Yeah, there's a company that I know of. I've been friends. Well, the owner's retired now. The next generation is
Hmm.
taking over, but they got a government grant to put in a robot, right?
Mm,
And they tripled their business by putting in a robot to do one thing 3 days a week. Like tripled their revenue
incredible.
to run 3 days a week with a robot because they were able to secure a job.
Yeah.
Like it's insane what digital transformation or industry 4.0 stuff does for a company. It's just
Hmm.
a lot of people they're not searching and trying to solve the problem.
Yeah, you're right. It's kind of a two-prong thing, though. It's on us too as software manufacturing software developers to get that word. And that's what we're doing here, right? I mean, we're getting that
Yep.
word out. Hey, everybody, if you just invested this, right? And they're businesses. I don't think we're trying to sell anything. We're just telling them robots. They're
Yep.
affordable. Like there's easy to program, right? Don't be intimidated by them. I know SolidWorks, Delmia has some now that is able to run robots, and right there, right on you. How long do you think it would take somebody to get a robotic arm to get it running? And this isn't a pitch. I'm curious because I've never really
Yeah.
dealt with robotic arms.
You know, if you're talking like let's talk like a small industrial robot, right? And I'll pick a Fanuc because that's the last one I was around. You know, let's say you were going to go buy one. You know, again, assuming you can get one in a relatively short time, right? There's a little bit of a shortage of robots at the moment, but let's say you could get one in 30 days. You know, I've been going through. I'll just talk about our solutions because I don't know about anybody else's. I'm not going to pretend to know about anyone else's. So let's say you know you get the robot in place. You have a seat of SolidWorks. Everybody knows SolidWorks these days. To put that in Delmia, you know, you use our library, you drop it in, you start moving stuff on it. 45 days, assuming you get the robot in 30. I mean, it's not that hard. Like, you know, when I went to learn our robotics programming stuff, to be honest, like I'd been working on the machining side previously, right? So I understood the environment, but I literally got like a 10-minute crash course. And they're like, you click these 5 buttons and it makes it do it. And it's like, oh, well, shit. This is easy.
I can do that.
Yeah, I was like, even for a Neanderthal like me, like this makes sense. Like, you know, it works. So, you know, you're talking a pretty fast ROI on that stuff these days. You know, is it cheap and free? No, but let's be realistic. Is there anything that's free that's good these days? Probably not. If it is free, it's a bait to get you to pay for something else.
Nothing's free, man, ever.
No, nothing's free. I mean, you know, to connect to the internet to get access to the rest of the world, you got to pay. So, you know, it's an interesting time. But I can tell you, like, some of the stuff that I've seen, like with the robotics, just being able to easily program that and send it out. This is stuff, it was sci-fi to me. You and I were talking about offline.
Me too.
It's sci-fi.
Yeah.
You know?
Yeah, for sure. You know, I went to some bigger shops that had some robots, Pelican case, those big plastic.
Yeah.
They have a robot. So you can imagine how big their injection molds are. So they had a robot with suction cup, grab the part, come off, demold it, cut the sprues off with a hot knife, and then drop it onto a conveyor, you know, and just think about the amount of time that saved for them. And Haas, I was lucky enough to get a tour of the Haas plant during Haas days. I mean, their machining cells are awesome.
Yeah.
But these big companies, I think now it's becoming a little bit more accessible. Like we were talking before about machines being accessible for the average person. Well, same thing with robots.
I mean, you can go to Tormach now and you can buy their mill and their robot, and you can literally in your garage automated system to run lights out. I mean, you want to talk about how different the world is from, you know, when you and I started.
Of course, my neighbors would probably set my house on fire running a mill 24 hours a day, but yeah, I could do that.
you just got to move out closer to me, man. There's plenty of space.
Yeah, that's right.
There is a question coming in. What's more important, being a machinist, a designer, programmer, or an operator?
Well, importance. I mean, I think they're all definitely. I mean, you can't have a manufacturer without any of those, right? So, yeah, I mean, you need somebody to press the button, right? So you need an operator, right? You need somebody that does the setups and the jigs and knows how to do it and do it right. I mean, that's really, really important. You know, you need a good design engineer, right? That can make something, right? So, what do you think? I mean, is there a priority in your mind?
So I think the employee of the future will be able to do all of those. Although they may be hired for one of those over the other, they have to know how to do all of it, right? I
think I just heard a collective sigh over YouTube for that, because as machinists, isn't that what we do all the time? Like, okay, you're hired to run that machine, and then 8 months later, you're running 10 machines and sweeping the floors, you know?
Yeah, I think the silos are for the employees of the future. The silos are going to go away because the kids coming into engineering don't just want to sit behind a computer all day. The people out pushing the buttons want to understand more of the upstream stuff, and I think what you're going to see is more of that hybrid role. And I say that partially from talking to college kids about what they want, you know, that are going into manufacturing, engineering, and those components. But I think the other thing too is like, if you think back to the early days with you and I, like, remember when you used to have, and I'm going to exclude big companies before someone roasts me on YouTube. I'm talking about general manufacturing, not 25,000 engineer firms. But there used to be, every company had the designer that was on the staff, and then they had the drafter on staff. And the designer just sort of went over here and did all this crazy stuff, and then the drafter was the one that communicated. And when you put in parametric modeling for CAD, that drafter position changed. It didn't go away. What happened is the drafters moved upstream and started putting more input into design, and the designers were able to now start putting out theirs. So you actually gained two people to be able to help influence, where before it was just one guy with all the stress of designing the product and the other guy just communicating, you know. I think that, to me, that's what's going to happen, because people want to do more. Nobody wants to just push a button. Very few people want to just push a button, because it's not worth my time to push a button.
I don't know, man. Some days it sounds really great, man. Just
It
sitting
sounds
there and button presser, just but yeah,
for
you're
about
right.
30 minutes, and then I'm like, okay,
yeah,
this sucks. You know, where's my robot to push that button?
Yeah, for sure.
You know.
Yeah, for sure. But you know, I agree with you with the hybrid roles, and you know, it's a lot of things. It's access to information, right? I mean, we were talking about my friend of mine and I were just talking about how education has changed so much because of YouTube that we're on right now, right? Yeah. Anything you want to do, there's probably a 5-minute tutorial on YouTube for it. You know, so this folklorish knowledge that you and I have obtained through, you know, these older machinists and stuff, you don't have to rely on having a great job with a great machinist anymore, right? You can learn to be a great machinist. You know, obviously it takes more hands-on, I know, but you're talking about getting roasted on YouTube. Now I'm all nervous, you know, but
never read the comments. First,
I don't want to read
the comments.
No, I'm not going to read those things. But there's, now I lost my place. Now you got me all confused.
Well, so the follow-up here is, if you had to choose one of those three, where would you start? I think that was the root of the question, is like, if I'm starting out in this world, where do I start?
That is a great question. So I would definitely, I mean, if as far as a career path goes, I would start as an operator for sure, without a doubt, because it's probably the least, I don't know, stressful, I guess. I don't know. I guess it's pretty stressful. I mean, getting the parts in and out and getting them in with the spec and stuff. But I think doing that, you're going to learn a lot about blueprints, GD&T, general machining, feeds and speeds, material characteristics, machine rigidity, you know, all that stuff, table movement, heck, the Cartesian coordinate system. You're going to learn all of this stuff, you know, as an operator. And then you know, once you get that down, it's all about programming. And I'm biased because I was a programmer for the majority of my career too. So, you know, in my opinion, that's the job to have, is the programmer. You're running machines, you're creative, you're solving problems. You know, at the end of the day, hopefully, or the end of the week, you have something you can hold in your hand that you've actually made, like, hey, I designed this, and things like that. Yeah, I mean, becoming an engineer, something like that, in my opinion, you got to really want that. That's a lot of dedication. But yeah, well, go ahead.
I will argue until the day I die that you cannot be a good engineer unless you understand how things get built. So you know, like, the guys that used to work for me would go out in the shop once a week or once every couple weeks, and they would go work with the person on the project that they just designed. And I'm not just talking like stand there and watch. Like, when we were welding up frames, like, they helped fit everything together. They helped the press brake guy run the press brake. They would move carts in and out of the paint booth. Like, they did all of the aspects, because a lot of times what they found is, oh, I didn't think about this. I could easily change this design, and we could laser cut it different, and it would save this person picking up that great big 4x8 sheet, right? And I truly believe that if you do not know how to manufacture something, and you've only ever done it in theory, you are not as good of an engineer as you would be if you come from the other way. Because some of the best engineers I've ever met started in a machine shop, or built hot rods, or did something to where they understand how things go together.
You're absolutely right. Yeah, you're absolutely. I will agree with you 100%. You know, to be there, and again, there are good engineers out there that may have never run a machine, you know, just to put that blanket statement out there. But you're right. I mean, the best engineers that I have worked with were ones where I didn't have to go back and ask, hey, is this important? Or, hey, how do you think I'm going to cut this? Because it's kind of impossible. Those were the best ones. And I'm not just saying because I didn't have to get up off of my chair to go talk to them or out of the shop. I mean, they were the best because I didn't have to worry about the part coming out right because they knew how it was going to be made. They had an idea how long it was going to take and the process to do it. And, you know, it's all about expectations and meeting expectations. So, yeah, absolutely. I mean, having even the most rudimentary idea of how to machine and just run a manual mill and a manual lathe for a little while, it speaks volumes. And, you know, to have that environment, Mike, where to work for a company where engineers are actually down in the shop is, well, you know, is rare. But I really do think that, wow, what a great solution. And I bet the products that came out after that were pretty awesome.
We did some amazing stuff, and the world really changed for the better when we started doing that. And you are right. There's a culture problem with a lot of companies not allowing manufacturers or allowing engineering to go down on the floor. And my only answer to that is shame on that company. Because if you really want to make the best products, everyone has to communicate and collaborate. And that old way of thinking of, well, engineers sit in the office. No, everyone has to understand what the other person's job is to make the world a better place. So with that, we have about 3 minutes left. I got a question for you because I asked this of everyone that used to go out and sell software at some point. What is the weirdest place you have ever done a demo at?
I don't know that I can tell that to the public. But let me think of the second weirdest place I've ever done a demo at.
Okay. Statute of limitations. No, we're good.
Exactly. Yeah, that's right. My parole officer advised me to not tell that story. The weirdest place, this is a true story. It was in Central California. It was this guy's shop, and he wanted to buy CamWorks. He had SolidWorks. He was going to buy CamWorks. But his shop was so small and he didn't have an office and he wanted to have all his guys. So I absolutely 100% did it in the parking lot, projecting CamWorks onto the side of the building. I'm not even kidding. So they could see it. So all of their machinists can see it and stuff. People are driving by and just giving me like the weirdest looks in the world. I mean, yeah, that was definitely the weirdest demo I ever did for sure.
That's a good one. I think that one's towards the top of the list of all the people I've asked that come from our background. So I can't thank you enough for being on, man. I gotta do a little bit of housekeeping here enough, and then we'll wrap up here. But next month we are doing a Titan trifecta. It'll be Manufacturing Live and the 2 other live programs that we have here at SolidWorks. We'll actually be down at Titan's place in Texas. It's going to be really cool. So next month on Tuesday, Titan and I are going to sit down and we're going to talk about manufacturing and processes and work holding and all of the cool stuff that Titan's doing these days. But until then, please share this video and reach out to Chris and ask more questions because he is one of my all-time favorite people that has been around the block and understands a lot about the world that we live in today. Chris, I can't thank you enough, man. I hope we can get you back on and hopefully people will reach out and ask more stuff.
You know what? I love talking manufacturing with everybody, and you especially, Mike. So thank you so much. And yeah, we're going to talk soon for sure.
Now, as grumpy old men, we'll leave with "Get Off My Lawn."
That's right. Get off my lawn.
Thanks, everyone.
Thank you.